All right, to solve this problem, the first thing we're going to need to do is figure out what values x cannot be. So in this case, x cannot be equal to 2 or -1. The next step I'm going to do is I'm going to factor everything out. So if we have x plus 3 over x minus 2, that's already factored. Same with the x minus 2 over x plus 1. And then I'm going to factor the denominator of this rational expression on the right side of the equation. So it's going to be x minus 2 and x plus 1, which still does match with our possible excluded values for this problem. So let's keep going with it. I'm going to multiply both sides by the x minus 2 and x plus 1. Then I'm going to distribute everything. This is all going to cancel here. Multiply it out here. You're going to get x plus 3 times x plus 1, since the x minus 2s are going to cancel. And then when we distribute it over here, you're going to have x minus 2 quantity squared, because the x plus 1s are going to cancel. And this is equal to 9x squared there. Okay, we are going to have a quadratic, so I'm going to have to simplify everything and set it equal to 0. So I'm going to distribute everything first. So you're going to get x squared plus 4x plus 3 plus x squared minus 4x plus 4 is equal to 9x squared. Okay, the 4x's are going to cancel, and you're going to be left with 2x squared plus 7 is equal to 9x squared. I'm going to subtract everything on the left side of the equation on both sides. So then you're going to end up with 0 is equal to 7x squared minus 7. Okay, if you factor out a 7 here. All right, so we're going to factor out a 7 over here. So you're going to have 7 times x squared minus 1, and then you're going to have two answers here of positive and -1 because of solving for this factor right here. Okay, but if you notice, -1 is actually one of the excluded values here, so your final answer can actually only be equal to +1. So x equals +1 is your answer for this one. Okay, let's go to the next one. All right, for this next one, first thing I'm going to do is figure out what values I cannot set x to, and that's -6 and 3. Okay, next thing we're going to do is factor everything here. So it's going to be 3x minus 1 over x plus 6. That stays the same. So does this second one here. But this one here, the denominator will factor to x plus 6 and x minus 3. Okay, I'm going to multiply both sides by that x plus 6 and x minus 3. So you'll get 3x minus 1 quantity times the x minus 3, since the x plus 6s are going to cancel. And then you're going to be left with 2x minus 3 times x plus 6, since the x minus 3s cancel. And this is going to be equal to -3x squared, since all of this is going to cancel right there. Okay, from here I'm going to expand everything out over here. So it's going to be 3x squared minus 10x plus 3 is going to be added to -2x squared minus 9x plus 18 is equal to -3x squared. Okay, I'm going to add 3x squared to both sides here, and you're going to get 6x squared minus 4x squared is, or minus 2x squared is 4x squared minus 19x plus 21 is equal to 0. Now this does factor, but it might be a little bit easier to use. Quadratic formula on this. But if you were going to factor it to be x minus 3 times 4x minus 7 is equal to 0. Solve this out over here. You have x equals 3 and x equals 7 over 4. Okay, the thing is, x cannot equal to 3 because it's one of the excluded values. So the final answer for this one is just going to be x is equal to 7 over 4. Okay, moving on to the next one. It says consecutive integers with the sum of their reciprocals equals 5 over 6. And it's basically asking, does there exist a pair that where this is true? Okay, so essentially what we're doing is we are adding 1 over some number, x, and we're adding it to 1 over that same number, only 1 over it, only 1 more than it. So for example, if x was 1, x plus 1 would be 2. So those would be consecutive integers. So one of the values is x and the other value is x plus 1. That's what we're looking for. If we find x, we're going to find those two consecutive integers, and they're supposed to equal 5 over 6. I'm going to write 5 over 6 in there. Okay, so now if you notice, this is similar to the other rational equations that we were looking at. So I'm going to solve it the same way I did before by multiplying both sides by the denominators. And what this does is, again, it gets rid of all the denominators to make the problem a lot easier to work with. So this one, you're going to have 5 over 6 times x squared plus x. Okay. On the left side, you are going to have x plus 1 plus x. Okay, we have a quadratic equation here, so we're going to set one side equal to 0, but first I'm going to simplify all this. So it's 5/6 x squared plus 5/6x minus 2x minus 1, so that's equal to 0. So I minus 2x and I minus the 1 there. Okay, so there's nothing on that side anymore. Simplify this out. 5/6 x squared minus 7/6 x minus 1. Okay, I would use quadratic formula to solve this, but another way you can do it is actually multiplying both sides by 6. Okay, 0 times 6 is still 0, so now it's going to be 5x squared minus 7x minus 6. You know, from here, this actually factors, but again, if you wanted to, you could use quadratic formula. We'll factor to x minus 2 times 5x plus 3 is equal to 0. So this would mean the possible answers would be x equals 2 and x equals negative 3/5. Now we're looking for integers, so negative 3/5 would not actually be considered an integer, but because it's not a whole number, but 2 is an integer. So 2 can be one of the answers, and then the x plus 1, so x is 2, and the x plus 1 would be 3. So the two consecutive integers would be 2 and 3, because 1/2 plus 1/3 is 5/6. So these are those two answers, those two values, and the answer is yes, there is two consecutive values. It's 2 and 3. All right, the next one, this one asks, or this problem is similar to the last one we just did, only this time it's consecutive integers with the sum of their reciprocals equaling 3/4. So this time it's going to be 1 over x plus 1 over x plus 1 being equal to 3 over 4. Okay. Same rules apply though. I'm going to multiply both sides by the denominator, so x and x plus 1. Do the same thing over here, so multiply it by x and x plus 1. And you're going to be left with x plus 1 plus x is equal to 3/4 x squared plus 3/4 x. Okay, just to make things a little bit easier, I'm going to multiply everything by 4. So then you're going to get 4 here, here, here. That 4 cancels, that 4 cancels. Okay. So now we're going to be left with 3x squared minus 5x minus 4, setting that equal to 0. All right, so to solve this, I'm actually going to use quadratic formula. So it's going to be x is equal to 5 plus or minus the square root of 25 minus 4ac, which is going to be 4 times 3 times negative 4, which is negative 48. And we're dividing all this by 6. Okay, this one becomes a plus plus, and you have 25 plus 48 is 73. So you end up with 5 plus or minus the square root of 73 over 6. Now, it says consecutive integers, which would mean whole numbers. This is clearly not a whole number because it's irrational because of the square root of 73. So the answer for this one is no solution. So the question does say, is there two consecutive integers such that if you add their reciprocals, it equals 3/4? And the answer would be no, there is none, because there's no solution for when you try to solve it out.